Synchromesh gearbox. We know that gearbox are mainly of three types: sliding mesh gearbox, constant mesh gearbox, and synchromesh gearbox. Now let's discuss synchromesh gearbox in detail. Synchromesh gearbox is an improved version of the constant mesh gearbox. It is very similar in construction to the constant mesh type, as all the gears on the output shaft are constantly in mesh with the corresponding gears on the lay shaft. Similar to the constant mesh type, the gears on the lay shaft are fixed to it, whereas the gears on the output shaft are mounted on bearings so that they can rotate independently of the output shaft. The improvement in the synchromesh gearbox is that it is provided with a synchronizing mechanism, which avoids the requirement of double declutching. This mechanism works on the principle that the parts which are to be engaged are first brought into frictional contact to equalize their speed. After the speed is equalized, these gears are engaged smoothly. A cross-sectional diagram of a typical synchromesh gearbox can be shown as: here A is the output shaft. B and C are the gears on the output shaft which are constantly meshed with the lay shaft gear. Member F is the synchronizer hub, which freely moves on the splined output shaft. G is the ring-shaped splined synchronizer sleeve, having internal gear teeth which fit onto the external gear teeth of the member F. K and L are the dog teeth provided on the gear B and C. These dog teeth also fit onto the internal teeth of synchronizer sleeve G. S is the shift fork which is directly attached to the selector mechanism. T is the spring-loaded ball which prevents the sliding of sleeve G on the hub F. 6 of these spring-loaded balls are symmetrically placed circumferentially in a synchronizer hub. M1 and N1 are the internal cones of the synchronizer hub, whereas M2 and N2 are the external cones provided on the gear B and C. Now when the driver selects a gear, the shift fork S pushes the sleeve G along with the synchronizer hub F towards the appropriate gear, say gear B, till the cones M1 and M2 start rubbing with each other. This rubbing makes the hub F and the output shaft rotate. When the sleeve G is pushed further, the friction between the contact surfaces M1 and M2 increases, which makes their speed equal. Further pushing the sleeve G to the left causes it to override the spring-loaded balls and get engaged smoothly with the dog K. Now the drive is transmitted directly from the gear B to the output shaft through the synchronizer hub F. Similarly, for the gear C to be engaged, the members G and F are pushed to the right till the friction